This is my CHUMP 4-bit counter breadboard prototype. The purpose of this project is to be able to control and pace an indefinite 4-bit binary count. In the grand scheme of CHUMP, this part of the project builds the program counter. The program counter will spit out the desired instruction from the 16 that could be executed. 4-bit counting is done by creating a clock and using the SN74LS161 chip. This chip counts in binary based on the clock input it is given on pin 2. The chip can also load any given instruction with the next clock cycle. And it can clear the count back to 0. The SN74LS161 is a 4-bit counter chip. It counts by aligning 4 JK flip-flops in series, where the enable pin of one is connected to the previous output of another. Next comes the clock. The clock can count in two options. The first option is an astable count, where a 555 timer IC chip is manipulated with capacitors and resistors to create a constant fill-drain cycle oscillation. The second option is a monostable trigger, which is a simple PB&O button, but uses the 555 timer to create a debouncer. Here's what can happen if the button isn't debounced. Since only one of these options can be used as a clock input, a debounce switch, along with a NAND gate chip, is used to determine which option will be the clock input. Astable when the switch is high, and monostable when the switch is low. In this circuit representation, you can see that the select switch is used to determine whether the astable clock will be the output or the monostable button. Lastly, before going into the 4-bit counter input, a halt feature is added to this output. This wire is used to freeze the clock count at any given moment. This is done by adding the clock output to another NAND gate contraption with this halt wire. Altogether, when plugged into the clock input of the 4-bit counter, you can control the speed of the clock cycle, or have a manual clock count, load the output to any given number, clear the output to 0, and halt the count instantly.